Okay, so after a lengthy deliberation, y'all decide to do insertion sort on a linked list. Cool. All right, let's do it. So I pulled over the code from our previous class code with the singly linked list. Let's see. Let me take a look at it. Looks like we're good to go on multiple fronts. So let's go ahead and at least build the list with a couple more elements. So it has 10, 9, and actually 11 in front of that. Give me some other elements to push to the back. 50, all right. Anything else? 22. You okay, man? All right. -5. Oh, bet you forgot about that.
Oh no.
-8. Poor -8. Anything else?
No.
Null. That's just 0.
No.
Good luck. I wonder if the compiler would yell at me for that. It did. Oh, it was just a warning, so we're gonna let it happen. Next. Come on, another number. 2. Great. All right, and then we did print. So let's make and then run it. Didn't care? Great. So that's our list. Is that list sorted? Nope. All right. Okay. So let's go do this. We're going to go in our header file. Let's do void. We said insertion sort, right? Notice I'm just calling insertion sort. Since it's a linked list, all the data is inside already, so we can just move it from there. All right. Let's go ahead and get this guy all set up. Yes.
Oh, I was wondering, can we add another value to the thing, like have a duplicate, like another 50 or another 2?
Sure. For you, Perry, of course.
Only for Perry, my dad.
How's that?
Better, thank you.
Not a problem. Good test case, by the way. Good test case. All right, so we have insertion sort. Let's go ahead and at least call it. We'll print it, and then we'll do list insertion sort. And then we'll print it again. So obviously the second printing should be in sorted order. It's not because we haven't done anything, but now we've set up at least a basic test case for the happy path of our insertion sort, which is the first thing you should always set up when you're coding this. All right, great. So we have insertion sort. How did insertion sort work? Well, let's do some comments. What was step 1? All right, make a link. All right, start a new linked list. Okay.
Add the first value.
Okay. Add the first value. Great. Let me help you out. For the rest of the linked list, or I should say, for each node of the linked list.
Compare with the ones listed.
Yeah, find the location to insert. Find the location to insert into the new linked list. And of course, insert it there. All right. Are you following me so far? All right. And then what happens after our new linked list is ready to go? Yeah, right. Update the original linked list. Right, because we now need to make sure it's pointing, mhead's correct. Update mhead and mtail is really what it comes down. All right. So start a new linked list. All right, this shouldn't be too hard, hopefully. So we got SL node of whatever the type is, and we'll tell it new list equals mhead. Right? It's going to start pointing at the head. Okay. Add the first value. Hey, look, we did that as well. Perfect. All right. Now for each node in the linked list. Okay. Yeah, so let's go ahead and make a rover. Rover equals mhead dash get next. I think that's how we coded it. Let me make sure. Get next, it sure is. Perfect. Find the location. All right, so then we go while rover does not equal null. Let me go ahead and set it up so each time. Oops. So we're going through it all. Let me, of course, the ending needs to be rover equals rover dash next. Kind of. All right, so rover is going to point to the value we need to add. We need to find the location to insert into the new linked list. So what does that mean we need to do? Right, to the old linked list. Correct. Now this is where things get a little tricky. You want rover to start there, but you want the new list dash set next. You want that to be null. And the reason for, let me see if I'm allowed to do that. Did I put my setters up here? I did. Perfect. So the point here, what am I doing? Well, let's go back with this. If y'all needed that, I'll hopefully upload it quickly. Thank you again, whoever reminded me to upload videos. Yes?
Shouldn't it be rover equals rover dereference and then get next?
That's what the arrow is.
Because it just says next in the code down in the while.
Oh, that get next, right? There we go. Hey, let's see if that compiles. It does. And then weird things happen. That's okay. All right, what's going on here? Well, we're setting, what is this? New list? Good. New list equals to 7 going to null. And then rover is equal to, well, points right there, right? Let me go ahead and actually write this out so it makes a little more sense, because just realized doing it that way is going to confuse you. Rover goes right here. New list goes right here. And then we're making the first one go to null. All right? That's what we've done up to the beginning of the while loop. Let me jump over to the video for y'all. We've set the new list to point to the head. We've set rover to go to what the head was next, so the 5, because originally it was like this. New list goes here, rover goes to the new list next, which is the 5, and then we set 7 to go to null. This, of course, being the new list that we want. All right, so while rover is not null, we're going to basically compare this 5 and figure out where it needs to go. So where does this 5 go? Or how do we figure out where the 5 goes? Find the location to insert into the new linked list. Well, what do we got to do here? So, what was it? Another for loop, right. For node sub t, we'll call it new rover, equals what we got? New list. New rover does not equal null, whoops, null. And what do we got? A new rover equals new rover dash get next. Ooh, that's confusing. But you see the new rover is just iterating through the new list. Right? Because it's going to point here and it's going to go through. All right, what are we checking? We're trying to check the values. All right. So, yeah, we're going to do an ascending. So if, what's that? Okay. Well, we want to keep track of prev. So we're going to SL node sub t, I'm going to call it new prev, new previous, equals, I'm going to start at null, because the previous to the new list is null. But if the new rover get value happens to be less than new rover whoops, I did that backwards. Get value is less than rover dash get value. And then we're going to have new prev equals new rover. All right, what is this doing? Let's go back to the picture. So we're going to have new rover. Start at the 7, right? We good? So new rover starting at the 7. That's what this code is. New prev is going to be null. Notice new rover starts at the new list. New rover starts at the new list, which is the 7. And new prev is going to start at null. Okay, great. Okay. It's going to compare new rover. Oh, then if new rover's get value 7 is less than the rover's value, then you're going to update new prev to be new rover. So in this case, does anything happen? No. Why? Because the 5 needs to go before the 7. It's going to make a little more sense when we do more examples. So at the end of this, you do need to do a check that if, so in this case, new prev equals null if we insert to the head, then we know that, let's see what we got. Then we know that rovers dash set next needs to be new list, because then you know that this 5 needs to point to the 7, right? And then of course that also means that new list dash or new list equals rover, because then you're going to want to update the rover to this guy. Okay? Now there's an error here. Does anyone see it? Not that guy. I think I might need to get like a Nerf gun or something. That might be a little more fun. Don't they make like a Gatling gun or something? But then I have to pick up the dart.
You just stand over there and point by just shooting the dart. And sticks, that's what I was talking about.
Okay.
It's not the 80s anymore. They'll see.
Yeah, that's a problem, right? I mean, lame. Bueller. Okay. All right, let's go and do this pictorially on the board so you can see what the problem is. So if new prev is null, oops, we're on the next part. If we insert to head, so new prev is null. So what that means is we're going to have, oops, what was the first step we did? Rover dash set next equal to the new list. So this 5 is now going to point to the 7. All right, that was this first line of code right here. And then new list is rover, meaning that new list is now going to point to the 5, right? So is new list sorted? Yes, it goes 5, 7. It's just weird because of all these arrows right now. All right, so now what's going to happen? Rover equals but what's rover dash next right now? It's what? Well, we accidentally updated rover's next to be the 7, so we don't want rover to go to the 7. We want the rover to go to 33, right? Right. So we got to come up with a different way to go about this. Yeah, we need another temporary variable. To make this a little more sense, while rover does not equal null, we'll have m head equals rover dash get next.
Just out of curiosity, could you swap the value by chance rather than the node itself?
Yes. The reason you don't want to do that is because if the nodes are very large structures, maybe megabytes, then it would take a very long time to swap the elements instead of swapping the pointers. You're swapping the pointers is always a fixed amount of time. By the way, since you're using pointers, your machine is optimized to do pointer operations very quickly. Yes?
If you just swap the variable with the, I guess like the index value, and then like still memory added and then still be the same, would they be different if you just swap the variables?
You mean if I swap the 5 and the 7?
Yeah.
In this case, no, but that's not how you sort linked list. Like I was telling him, this is an integer, so yeah, that might be just as fast. But if your if the data was an integer, maybe it's a record for a very large piece of information that's in megabytes, you would have to swap megabytes of information as opposed to just some pointers.
Okay.
So you want to stick with pointers. So mhead rover-next, which means that you actually want rover to be mhead, because what's happening here on the board is mhead is pointing to 33. And I think I put mhead in the wrong location. Okay, that's good. All right. Mhead's up here. All right, let's do this in the next iteration. Hopefully this will make a little more sense, and we'll start ironing out a couple of situations. Because, for example, we haven't talked about what happens here. You know, we haven't gotten to this part, but we haven't drawn it out. By the way, when you're doing these algorithms, please draw it out. And let me go in here and space this out a little more, because I just realized this is pretty hard to read. Okay. So next iteration, hopefully this makes at least some sense. Hopefully it'll make a little more. We're on the next iteration. What's the first thing we do? Update mhead to be rovers-next. Well, we check first, sorry. Is rover null? No, rover's not null. So we are going to continue our loop. Over here, we actually had rover equal to mhead, so I forgot to do that. So rover points to where mhead is pointing. The 33 is rover null? Nope. So what's the first thing we do? We set mhead equal to rover-next, which means that mhead is now going to point to the 2. All right, good. You're good. And we can get to it because rover-next is 2. Perfect. Okay. Now we create a new prev, set it to null. Great, we've done that. We create a new rover, and where does that start? Where is new rover going to start now? At new list, right? New rover equals new list. So where is it beginning? At the 5. Great. I know it's getting a little messy. I'm going to go ahead and take a step back. Let me rewrite this so it's a little easier to read. But hopefully you can see that doing it 5-7. So you know new list is at this 5, 7, and then that goes to null, and then you know new rover goes up to the 5. All right. Hopefully you can see I didn't change any of the values. I just rewrote it so it's easier to read on the board. Everyone good with that? Yes.
Should we run into an error when we run into 0? Because 0 is the equivalent of null.
No.
The value.
No.
No.
No, because the value and the pointer are 2 different
Yes.
data pieces. So yeah, you wouldn't run into a problem. All right, so new rover starts at 5. Is new rover null? No. So what's the first thing we do? Wow, my arrows are not working. If new rover-get value is less than rover's-get value, so if new rover's-get value is less than rover's get value, is that correct? Yeah, so we're going to do what inside this if statement? Update new prev to be new rover. So then new prev is going to equal what new rover is pointing to. So it's equal to this 5. Okay. Now, what's the next? That's it for this for loop. What's the post statement? Whoops, for this for loop? New rover equals new rover-next. Okay. So new rover, right here is 5. It's going to be rover dash next. So what is the new rover going to point to? The 7, because the 5 points to the 7. Okay. Is new rover null? No. So we're going to check and make sure that's a null. Is 7 less than 33? Yes. So what do? New prev equal to the 7. So now he's going to point to that 7. And now at the end of the for loop, we increment new rover to point to new rover dash next, which is the null of this linked list. Remember, this is a separate linked list. So he's going to go over here. Now we check, is new rover equal to null? Yes. So we exit this for loop. All right. Is new prev null? No. No. New prev is pointing to that 7. So he's not null. All right. So what do we want to have happen here? We've already done that. So we know new prev, we know that this value needs to go after the new prev. Yeah, so we're going to want to update new prev. So new prev dash set next should be what? Rover. You got it. Right. Because what we want to have happen is we now want to have new prev 7, it's next. Now, in actuality, this guy's still pointing to null. This one's going to point to 33. Then what do we want? Because you don't want it to go 5, 6, 7, 33, 2. That's not correct. We want to terminate the 33, correct? All right. So we're going to do the same thing we did up here. Let's see. Rover set next is to null. Yes. Oh, I thought I'd answer. Okay. All right. Does anyone see the error yet? If not, it'll come up. And this, we're good so far with the example on the board, but we'll keep going. So set next is to null. So on the board, that means we're going to take this 33. It now goes to null. And then at the very end of this loop, we have rover equal mhead. Mhead was always pointing to that 2. So now rover is going to go and point to the 2. All right. Now, is this correct so far? Is 5, 7, 33 sorted? Right?
Yeah.
And we have a handle to the rest of the array. So we're not to the other little errors that we made yet, but that's okay. Let's go ahead and check back. That's the end of this for loop. So let's go ahead and go back up to the while loop. While rover is not equal to null, is rover null? No. Make mhead point to the next. Great. New rover starts at the new list. So we're going to have new rover, instead of going to null, he's going to start right here at that 5. And did I forget to update the prev? Oh, I forgot to update prev to null. And of course, prev starts at null. So new prev is null. Rover starts at the new list. While rover is not equal to null, make it go next. Okay. Now we're in this little loop in between. Is 5 less than 2? No. So we're not going to update new prev. In fact, new rover, we could exit early, but just to make this code work, it's going to compare against each one. None of them are less than 2, so at the end of the day, rover is actually going to be pointing to null. And so is new prev. So that means we're going to enter this for loop, this loop right here, which means that rover dash set next is going to be new list. which means that this 2 is now going to actually point to the 7, I mean to the 5, sorry. Because that's what this line of code does. Point to the next one. And then new list is equal to rover, which means that new list will now point to 2. So the new list goes 2, 5, 7, 33, null. Now, everyone following me so far? So to make this easier, because you can see it's all jumbling around, I'm going to move this 2 over here. So new list points to that 2, and of course rover is also pointing to that 2 at this moment. And then we can get rid of all these arrows so it's easier to read. Okay. Great. So we exit this if else, rover is equal to imhead, which means that rover, instead of pointing to the 2, it's going to now point to the 18. All right. Okay. And I think this is I think this is the iteration where we're going to find our last error, and most of this should make sense. While rover does not equal, rover does not equal null. Is rover null? Nope. So what's the first thing we do? We update imhead to point to the next one. All right. Great. We make prev start pointing to null. Oh, good, it's already doing that. Convenient. We make new rover point to the new list. So new rover is now going to point to the 2. Perfect. While new rover does not equal null, rover dash next. Great. And now we're going to compare new rover's value with regular rover's value. So new rover is 2. Rover is 18, so it's 2 less than 18?
Yes.
Yes, so we're going to have new prev. I'm going to have the arrow over here for now. Point to that 2. We increment new rover to go to the 5. Is 5 less than 18?
Yes.
So now new rover is going to go to that 5. Increment new rover. New rover is not null, so we're going to compare the 7 versus the 18. Is 7 less than 18? Yep, so we're going to update new prev to the 7, and then update rover to the 33. Is 33 less than 18? Nope, so we don't update prev. We do increment new rover to point to null, and we're done. We're done with the for loop. So you see after that loop, new prev is pointing to the 7, and we've gone to the end of the loop, but we need to put the 18 between the 7 and the 33. Okay? All right. Everyone with me? Okay, good, good. So we go to the code, new prev equals null. That's not what's happening. New prev dash next equals rover. Well, hold on, here's the problem. Because if we do new prev dash next equal to rover, we would make that happen. Is that what we wanted? No. So, because we need to save this link. So it is the easiest way to do this, in my opinion, is just create the link again. We'll call it new prev next, which is equal to, of course, new prev get next. All right. Now that we've had new prev next, is going to point to where new prev's next is. So he's going to point to that 33. That saves this link, is what I'm doing. I'm saving this link so that later I can use it. Y'all see what's going on?
Link 33.
The link between 7 and 33, this arrow right here, I'm saving it in this variable. It's essentially what I'm doing, because I'm copying the memory location of 33. That way later I can put that memory location back. Okay? So now, what's happening? Now we've saved that location. We can now set the next to rover. which means that 7's next will go to the 18. And then we want 18's next to be what? Yeah, new prev next, right? So we actually don't want this to be null, because remember that's rover. We want it to be new prev next. So if we go back here, then a rover, which is currently this 18, will go and point to where new prev next is, which means this 18 will now go to this 33. All right? Then, now that our if statements are done, rover equals mhead. So mhead's pointing to the 202. We'll go and erase this. Put this guy all the way over here. All right, how are we doing? Doing good? All right, we got one last iteration. Is rover null? Oh, you have a question?
Just to go into like the example of the one you have on the computer, would you have to set like a whole new thing for them to be like, say you had like another 18, would you have to have a whole new like test to see if they're equal to each other, or would it kind of run the same if it's the same value? Like,
Oh, you mean when there's duplicates?
Yeah.
Let's address duplicates later. Okay? But do ask me again. Let's finish this out because we're almost done, and I think we'll get this ingrained. All right, is rover null? Rover is not equal to null, so mhead is equal to rover dash next. All right, mhead is equal to rover dash next, which of course is null. That's fine. Update new prev to be null. Great. And then create new rover to start the new list. I'm going to erase this because that was a temporary variable. So new rover starts at the new list. All right, great. Is new rover null? Nope. So while new rover, yeah, if the value is less than the other one, update the prev. All right. So is 2 less than 202? All right. So new prev right there. We increment the new rover to go to the next value. 5. Is 5 less than 202? Yeah. So we're going to put the 5 right there. Increment new rover to the 7. Is 7 less than 202? Yes. Come on, loud and proud, guys.
Yes.
All right. Thank you, Perry. Oh, thank you. New rover will go to the, oh, it doesn't go to the 33. It goes to the 18. Is 18 less than 202?
Yes.
Yep. All right, thank you, guys. So we're going to, yeah, we'll go up here. Now, new rover is going to point to the 33 because 18 the next is 33. Is 33 less than 202?
Yes.
Yes. All right. So let's update this to point to a 33. And then new rover is now pointing to null, so we exit the loop. New prev is equal to null? Nope. So we're going to have new prev next equal to new prev dash next. All right. Because new prev's next is null, so it's going to be null. All right. What's the next thing we do? New prev that's set to next equal to rover, so that means we're going to take, well, use null right now. We're going to set the 33 to point to the 202. Okay. And then we have one line left. Rover dash set next is new prev next, so we're going to have rovers, which is 202, is next to be equal to null. It's already null, so we're perfectly fine. And now, is that linked list sorted? Yes, all right. Well, you ready to see if we coded this correctly? Sure, why not?
I'm assuming something.
Oh, of course. Let's see. No, it had to be something. Has no member get value. Maybe I called it get val? Yeah, get val. Bet you that's what happened. Ooh, it turned into nothing. All right.
It's gone.
Oh, you know what we didn't do? We did all the work. Put step 4. But chink. All right. M head is equal to what? Yeah, new list. And now M tail. We gotta just let's do it the easy way. That does not equal null. M tail equals M tail. Get next. There. Start the M tail at the beginning of the list. While its next is not null, make it go to the next one. AKA keep going down the list until your next is null. Because once your next is null, you're at the tail. Alright, so we'll update M tail. Cool. No whammies, no whammy. Yeah, there we go.
I see it.
Yes.
Don't you then have to delete the first list? The original list?
No.
Why not?
Why don't we have to delete the first list?
Because it's still, I mean,
I didn't make anything new. I just rearranged a bunch of pointers.
Okay.
I didn't allocate any new memory. Yes.
Is there a reason there's a semicolon in that for loop at the end?
No. Well, I mean, yes. I just write it this way for simplicity so that people know that, hey, look, this for loop is empty. And I'm just explicitly making that obvious. You don't have to do it this way. This is just my way of, hey, look, it's a simple for loop. Nothing crazy going on here, guys, okay? It's all done in the for loop. Yeah, nothing crazy going on here, okay? Simple for loop. We're not doing anything fancy. Next question. So duplicates. Why were duplicates okay? Well, if you had two 50s,
It would just be less.
it would just be, whenever you add a new one, it'd just be inserted before the other 50. Does that matter? Not really. No.
Basically, the same test would work for duplicates as well.
Yeah, I mean, we could, if you wanted to be after that, you could do it this way. So if it's equal, but, you know, it doesn't really matter. But yeah, good point. We didn't have to free anything because we didn't have any news because we're just re-editing the list, which is great because we're not allocating any new pieces of memory except for some temporary variables on the stack. And then we talked about duplicates. Great. Okay. All right. Does anyone see the big error? Oh, there's a huge one. Oh, there's a... No one?
Well,
Yes.
whenever it's going through, since you have null going into the original list, doesn't it see that and think it's done?
I'm not following.
You go to the main. You see how you have list push back null,
Null is 0.
but doesn't it look for null and then it starts? Doesn't it
No,
think
null is
at
0.
the end when it's at null?
Null is 0.
Okay, but then in the code, whenever you're going towards the end, doesn't it look for null to think that it's at the end of the
Sure.
list?
Yes. But null is 0.
Okay.
We aren't accessing the value there, so that's why it doesn't.
Notice that the node has a value and a next. A null value is just 0. A null next is a pointer to nothing.
Okay.
So these two things are different. I'm always, when I do null, I'm comparing here. This is bad programming practice to put the null here, but I was just trying to make you think about what's happening. But null is 0. So it's fine. Yes.
Can we put a duplicate, like, say in the middle, just to test it one more time? Like,
Sure, why not? I love test cases. Here, 222s. Let's do it. All right, I did it.
awesome. Just want-
No, that's great. Anyone see it?
You never know, like.
No.
All right, well, you know your professor's evil.
I was like, I don't-
So what if we try and do insertion sort on an empty list? Womp womp. Okay.
So they fall. Wait, what?
seg. No. Wait, won't you have to put a test case in the beginning that if the if m head and m tail are null, then just
Yes. Okay, good.
That's what I remember. It says before you do anything.
If m head equals null, actually, or m head dash get next equals null, you're done, right?
Yeah.
Good. There we go. All right, fix that one. All right, that was the big error. It's a miracle. Okay.
Yeah.
So let's always try doing it with 1, of course. Let me actually comment out the right stuff. Details. Good, it can sort 1 item. Hey, look, it can sort 2 items. Let's put them in reverse order. Hey, look, it did it. All right, so there's some good confidence this thing is working. And we'll do it again. All right, any other tests, comments, screams? We're good? Kind of? Okay.
Is this SL just for integers?
Yeah, we can make it of doubles if you wanted to.
Could you make it like a template so it know like if there was a double and an integer, could it compare them and then?
What if those characters?
Yeah, well, whatever you set it to, it's going to automatically convert it to. So, I mean, we do. It didn't like that. Oh, yeah, because we have to make it doubles. Double all the way. Hey, it did the same thing.
What if it was some list of characters?
Then I would have to be putting strings in here, and then it would be calling the comparisons based on strings, and then which in the STL is in alphabetical order. So A, B, C, D, E, F, G, so forth and so on. Or lexicographical order is what the technical term is. Yes.
Would it know, like, would, I guess the sorting know if, like, say, if the list was a, like, template class, if there was, like, a 2.2 and a 2, that the 2 would be less?
So when you add to the list, it's going to convert it to its type. So even if I made these doubles, or I made these ints, and I tried to do pushback 2.5, for example, it's going to either give me an error or just added it as a 2, because it converted it to an integer.
Okay.
So that didn't really help. Naturally, if I made these doubles, then it should have done it. Yeah, there it is. And then there's the 2.5 right there. Yes?
If we were to do this comparison with strings, would it add random characters because of the less than?
It shouldn't, no. I'm not actually manipulating the strings. If you notice in the code, I'm not touching mval. All I'm doing, well, the only touch I do is comparison. I have it here and here, and then that's it. Those are the only 2 locations in this function I'm doing mval, and those are gets. So I never manipulate the value. I only do a comparison. Any other questions? All right. Well, let me do a make clean, get added, get commit -m, class code for insertion sort of a linked list. Go ahead and push it. Hey, look, some swap files. Well, you get some swap files. Sorry about that, guys. Oh, maybe it'll push. Okay, good, it did. All right, and then we're gonna stop the